You're listening to the Modern Mainframe, BMC's intelligent Z optimization and transformation podcast, covering the latest trends and issues on the mainframe and how BMC AIME and BMC CompuWare Solutions can help you build a mainframe-inclusive DevOps toolchain. Hello and welcome to the Modern Mainframe. I'm Matt Dallaire. Today we're discussing performance testing, specifically shift left. Joining me today are two guests with a lot of experience and knowledge on these subjects, so let's get started with the introductions. Dr. Elizabeth Maxwell is BMC CompuWare Technical Director for EMEA. She has a wealth of experience working in mainframe performance over the past few decades and has worked with customers of all sizes and industries worldwide in both realizing performance savings in production and in supporting the adoption of tooling from a development standpoint. Elizabeth's current passion is mainstreaming the mainframe and adoption of agile practices in development. Welcome, Elizabeth. Thank you for being here.
Hi there. Glad to be here.
Also joining me is BMC CompuWare Strobe Product Manager, John Dannenberg. With over 40 years of experience in the industry, the last 27 of them with BMC CompuWare, John has worked in a variety of roles which have provided him with perspective on the various ways performance can be affected. Those roles include computer operator, COBOL CICS programmer, lead analyst, DBA for ZOS DB2, customer support, quality assurance architect, and product owner. So hi, John. Thanks for being here.
Hi, Matt. Thanks.
So we'll jump right into the questions. The 2021 BMC Mainframe survey showed dramatic increases in transaction volumes, data volumes, application changes, and workload unpredictability. The survey also shows that 92% of respondents see the mainframe as a platform for long-term growth and new workloads. As enterprises prepare to innovate more quickly and respond to future market disruptions, they must consider the costs associated with CPU consumption as well as the effect of system response times on end users. How are you seeing mainframe platform owners being more responsive to business demands?
Well, the way I see that, Matt, is customers are a big part of business, and performance can affect the way the customers perceive your products. So I see the mainframe being the back end for many applications. So if there's a performance issue, you can increase issues with customer perception, saying your products may not be working well, there's lots of delays. So there's more importance onto keeping your customers and retaining those revenues. So the shift to mainframe attentiveness and performance is becoming critical.
Elizabeth, how would you answer?
Well, I think there's a huge amount of pressure on IT systems today, more so than there was a decade ago or even 2 decades ago, where people were more patient. You know, we're in a society now where a better service is really only one click away. Now, the mainframe is the backbone of many of the business services that we have today, and a very large percent, I think it was quoted as 80% of the world's business data resides on mainframes. So we're kind of at the end of the chain. Now, what's been happening on the mainframe platform is a complete reinvigoration of it, a reinvigoration or a mainstreaming of the platform. So we're seeing owners of mainframe technology and applications moving away from what we called an agile practice, waterfall practice, to an agile practice. And what that means is really that we're getting closer to our customers, understanding their needs, and evolving the software to meet those demands from our end customer with our technologies in a much more rapid fashion than we needed to in the past. Because all the upstart fintechs are all doing this, so we have to speed up and we have to be more responsive when we look at the mainframe technology. And testing forms part of that process. It's a big part of development.
There's also the aspect that development on the mainframe needs to keep pace with other development teams. As we come up with new services, the mainframe can't be the platform that's slowing things down, right?
Yeah, I mean, the mainframe is a critical link in a chain of events that goes from clicking something on your smartphone to money being moved, a transaction being made, and then coming back. And there's a number of layers in between. And those layers have traditionally, in recent times, operated quite differently from a mainframe. And the mainframe staff and the mainframe development community have really had to up their game and think about how they keep pace with the other technologies so that we can enable functionality delivered back to the business and a continuity of service to our customers that is meeting their expectations. And those expectations are fast. When you click a button on your phone, you expect something to happen immediately. You don't want to be waiting. What do they call it? Puffer, blowfish face or puffer face?
Yes.
When you sit and wait, we don't want any of that, and we can't have any of that.
Right. So we also know from the mainframe survey that cost reduction, it's always an important topic, but it still is. So how is cost considered in an agile approach at the developer level? Elizabeth?
So when we think about cost, we're really thinking about efficiency of resource usage. With the most efficient approach to using resources, we save on costs because we're burning less fuel, we're burning less CPU, as we call it. So that's very important to us. And we're also looking at how fast you can get new functionality out to your business users. So those are two things that translate very well down to the development layer. Now, traditionally, development personnel have been focused on only the efficiency and the speed by which they can deliver functionality to the business. Usually in the waterfall approach, the cost angle was kind of somewhere further down the development waterfall lifecycle where it was being checked. But what we're seeing with agile practices is that a lot of the ownership of looking at things such as testing, events, efficiency of code is now part of the remit of a developer. So we're empowering, or we're trying to empower our developer to catch things, and there's something called fail fast. If you're going to fail fast before you push something into production, and it costs a lot more money because it's using a lot more resources than it should be.
John, do you have anything to add?
Yeah, I'd like to include that, cost is one part of the whole value stream. So when you start going agile, the value stream is from concept of idea to delivering to the customer. And as Elizabeth stated, is you want the quality in there, you want the testing in there. So the idea now is development is understanding the process better. They're understanding how the customer uses it. It's no longer just a lab where you're coding some syntax, you check it, it's right. They're now including the aspects, perceptions of how our users working with the product. So the value stream adds more overall by getting innovation out faster, allowing the developers to see if their code is working better, thereby increasing their knowledge and understanding of how more efficient coding works, and getting that satisfaction that the customer now is using something they've coded. So there are some intangible costs in there as well.
I think another aspect of cost, if we just look at it in the cold, hard light of day, is when you've got the code in your hands as a developer, you're interacting and changing that code in that moment, and it's part of whatever you're creating to make changes. But as you move more towards production, there is a point at which it gets passed and it gets deployed into production. And to bring that out of production and put it back into a development team's hands is a costly exercise. And you've lost reputation, let's say, because the performance has been bad and it's led to a bad customer experience. But you also have to pick it up and bring it back down to a team, or create a new team, because that team may have disbanded already. And you have to bring it right back into production, and you have to then fix it and do all your testing through your pipelines and everything, and then push it back up to production. So that in itself, the correction of any performance issues that leak into production is quite costly to do and takes time as well.
And that will also interrupt with new innovation, because now you've got to stop your new innovation to fix those issues.
As they say in carpentry, measure twice, cut once.
Absolutely.
So as you've said, many organizations are turning to DevOps and agile development to help them innovate quickly and meet changing customer demands. How is it possible in terms of performance when performance has traditionally been in the realm of operations? Elizabeth, I'll ask you first.
Sure. A key thing about any technology that we use today is that it has to be quite intuitive and really simple to engage with. So what we see in a lot of the tools that the ops side of the house or the system side of the house, a lot of these tools are highly specialized and don't really present information in a way that's easy for your average developer to digest. So I think one of the key things to have is a great interface that allows them to quickly see where they should be focusing their time, where the biggest CPU consumption spikes are, and then they can hone into those and they can question them. Is that what I anticipated, or is it actually a problem that I have introduced in the very creation of the code or in the maintenance of the code? So I think having a piece of software that a developer could easily switch on and look into and intuitively understand is hugely important to getting adoption of, looking at performance back into as early in the development cycle as possible. It's absolutely critical, because anything that's too hard, you don't want to use.
Right. John?
Yeah, I agree with a lot of that information. And another part is that the product manager working with the product owner in the Scrum methodology needs to make that evident in the story. They need to communicate that to a developer. If you have a new young developer coming in, they don't yet have the experience or may not have enough experience to see that. Whereas a veteran developer may have been coding the same way for many years and is still not aware of performance issues. So this goes against all levels of experience. So having an intuitive product that meets both a novice and an experienced person greatly helps in visualizing the differences in performance and being able to have a repeatable performance test so you can actually start seeing the effect that your code has before it gets promoted to production is a big part of performance testing. For example, a new coder may have two methods of coding something. Now, a performance test is a perfect opportunity to see what does that code do? What are the effects? So they can code one way, run the test, code the other way, run the test, and now they can see, and this helps to reinforce their coding methodologies.
And I think that common language and that common viewpoint is critically important, because if you don't have a common viewpoint and a point of collaboration where you can look at evidence and it's the same measure, then you are lost and you're guessing, and that's not good. And today we're all basing our decisions, action orientated decisions, based on analytics. So it provides that level of analytics that is a shared view. And just talking about that shared view and talking about guessing, I was involved with educating a lot of developers at a very big international bank. And the reason why this bank wanted to educate their developers into testing performance as early in the life cycle as possible was they wanted to save some costs in production. And they'd started looking at the real estate of one of their critical banking applications. And they'd started looking at it from what could be the biggest culprit. Oh, it's always DB2. DB2 is always using loads of CPU. So they started kind of almost not blindly, but picking off the big DB2 statements and tuning them. But then they weren't getting the impacts that they wanted. So they started having a look at the applications again, using the tool that we have. I'll mention it, using Strobe. And they had a look at it and they thought, it's not DB2. We can see in our top critical transactions, there are some coding standards which are problematic. And over the years, people had been kind of doing less code checks and stuff like that. So some of these little nasty things had sneaked into the code. And they looked at them and they thought, if people understood why they shouldn't be coding things like this, we wouldn't have this problem in the first place. So they went into this exercise of training people to use the tool so that everyone had a common view. The system programmers used it, the development, the DBAs, everyone was using it. And I remember sitting in a session with, I think we had 40 developers in a room, and we were doing some training with them. And they were using their own programs, they were having a look at them, and they're all getting very excited to understand where they'd written a good piece of code and where they'd written a not so good piece of code. And I remember walking up and down the aisles as you do, almost like sitting an exam. And someone said, "Oh my gosh, now I get it." And both of the facilitators, myself and my colleague, looked over and we said, "What is it?" And they said, "Now I understand the standards because I've just ran a program with a particular COBOL verb and I've now replaced it and ran the program again. I've measured both these programs and hey presto, those standards which people are asking us to follow, they now make complete sense." And that was a real eureka moment for the bank because they allowed and empowered people to have knowledge to make themselves better and understand in a measurable way the impacts of the code that they had written. And that was just a fantastic moment. And I think beyond there, they saw better and more improvement in the quality of the code that was being written because people could test it and evidence that it wasn't just a guessing game anymore.
Right, that's a great example. So, John, how does automation play a part when it comes to performance?
So automation is a critical part because it removes the manual effort that is usually involved. Developers need to set up tests, they need to set up data, they need to execute jobs. By automating these steps, they become repeatable. So now you've got consistency over time. Once they are automated, performance tests can be run after a unit test and a functional test. You have a logical order, you follow the testing pyramid. Unit tests are done first. If there's something that fails there, there's no need to go to the next level. So as your tests progress up in the automation stream, you've got a performance test. Now, the performance test doesn't have to be some large test that involves millions of transactions. It needs to represent a significant amount of data to be able to identify when something changes. So if you see maybe in your test bed, you've got 100, say, CPU seconds, and then if it jumps 10%, why did it jump 10%? Why did it jump 20%? What changed here? So having that automated test keeps it as close to the code changes as possible so that the developer can quickly go back and examine that code.
Elizabeth, do you have anything to add?
Well, I think having that automation in place, it really allows the developers to focus on the stuff that they're good at, and that is coding. All of this other stuff, the testing, the comparison, and everything else, it's all really vital, but it's not their main skill set. So, in putting in automation and using pipelines to do it, it really allows them to excel at that coding part of it, but still get the other bits done in the easiest way possible. And that's really the essence of technology, isn't it? It's taking away all that mundane stuff so that you can focus on the stuff that is really important to you. So, and this is like a revolution today, especially in the mainframe space, where we're seeing much more automating of testing, and then folding the performance testing into that is another fantastic step.
So this is kind of a multi-part question, but once an organization has decided to shift left with performance testing, how do they go about doing so? Where do they start? And what else should they look for in a solution? Well, Elizabeth, I'll ask you first.
Well, to me, I think when we're introducing new technologies such as shifting left in performance testing, what you're doing is changing a culture of how people work. You're changing processes, technology, and culture. So in my experience with the customers that I've worked with over many decades, what we try and do really is obviously make sure we have the right tool in place, that it's intuitive and it does things that we need to do, and that it can work in the bigger ecosystem so it can join into a pipeline orchestration tool or whatever the vision is within the customer. But it is just one piece of the picture, because the other piece of the picture is enthusing and educating people to use the tool. And what we find works really well is to start small with a pilot team and to get them to have some success with this particular approach, with shift left performance testing and kind of a fail fast type approach. So in getting traction with a small team who's maybe a respected team within the organization, what we do is we create a success story. And we create a success story, and then we start to, hold the light up to the success story across different teams. And we start to make this kind of infectious excitement at a customer. And then everyone starts going, how come those guys have got more time? How come they're developing faster? How come they've got less defects going, escaping into production? How come they're being held up as a good development team? And then we take that practice that we've been establishing in the pilot and we start sharing it and seeing how it can be adopted by the other application areas. So this is something that we see very effective to start small, do modeling, do a very tailored approach with the tooling to the particular organization's team and culture, and then to start to move this out and expand, kind of a land and expand of the approach, and create those stories of success to change the culture.
John, do you have anything to add?
Yeah, I think one thing to add there is, what do I start with? Which application? So there might be some service level agreements that you have with batch processing windows, and you've got a long running batch job. Those might be a candidate to examine for opportunities. A lot of these performance issues are technical debt. They've been occurring for decades. The code has been slipping through, and now it's becoming apparent with the increase of transactions and activity. These underlying coding styles are no longer sufficient. So finding what candidate to examine first will help make that a successful pilot. So if you find something, for example, say it's running 3-hour batch window, and somebody uses strobe, identify it, and they can see some deficient code. If they go into that code and change it, and they can drop that time down an hour, that gives that company an extra hour in their batch processing window to get other work done. And that also shows that, hey, if we made this change over here, what else is out there? So that technical debt is just sitting out there waiting. So you've got new development where you're looking at putting in new code, not introducing performance issues. But on the ops side, you've got the code that's already out in production that could be examined and save you time and money and issues down the road.
So, John, how does BMC CompuWare Strobe fulfill the needs of mainframe organizations looking to shift left with their performance testing?
All right, that's a good question there, Matt. I think one of the big items out there is the expertise base. So typically right now you've got performance analysts, and they exist on the ops side. And from my experience action with customers, I'm seeing this trend to shift left. There are fewer and fewer performance analysts out there. They find the issues, they have to send it back to development, and they see this repeated pattern going back and forth. They have other things they need to do rather than find performance issues. So the idea there is now put the onus, the responsibility back to development and say, guys, this is what we're saying. Strobe identified the issues in operations. We need to go back on the dev side and come up with some issues. So what I'm saying is kind of twofold. I see it, one where, say, DB2 SQL is being written more and more by developers without the experience or knowledge of understanding what happens behind the scene in DB2. So if you have an index versus a table space scan, there's going to be a big performance difference. But to the developer, they see the same data coming back. So logically, it looks correct, but performance-wise, it may not. Likewise with a COBOL program. If they do an open file, close file in the wrong place, and they're always opening and closing that file, they're incurring overhead. But if their unit test will function correct and end with return code 0 saying it passed. So this shifting left is a big part of trying to empower the developers to understand and take responsibility for coding, the QA work, the testing, and the overall picture of what happens once it's in production.
Elizabeth, do you have anything to add?
No, I completely agree with what John said, and I think the critical word for me is that empowerment. When you know how to measure something, you can then You can then interact with it, make a good decision about how to change it, and then check it again. We're all used to this in modern society with all the devices that we have around us. So why not apply it back into development? And it just, you only go one way with your development, and that is up with taking this kind of approach, because you're getting the right data and empowering yourself to make the right decision, knowing very well and being very familiar with that piece of code that you're working with. So you're the absolutely right person to make that decision, because you know what intervention you're making with the code. And if the decision that you make is maybe not the best performance one, you probably know what else you can do to change it and make it better. So I think empowering people at that stage is really important to make the right decision, to refine that decision, and then hopefully we have all the positive knock-on effects of that.
So we've already spoken about the benefits and what can be done, and we heard a good example of kind of a breakthrough with it. But how have you seen customers improve costs and quality by shifting left with Strobe? Elizabeth, I'll ask you first.
Well, all these types of things, costs and quality, efficiency, velocity, as we termed it in the industry as well, can be measured as KPIs. So the great thing about technology today is we're all about measurement. So one of the things that we did, particularly, we did quite a lot of research with Forrester about a couple of years ago, and we came up with these critical KPIs of quality, velocity, and efficiency. And we put them into an analytics machine learning engine that we have called Z-Advisor, which many of our customers use. Now, Z-Advisor captures information by which we can see, are we tracking up or down against quality, velocity, and efficiency, and the impactful cost of that. And it's a really powerful common measurement to see how you're getting on, because if you can't see how you're getting on, then you can't possibly make the right action orientated decision to improve it. So we see customers using these metrics, and I'd encourage customers to come and reach out to us, and we can show them what the rest of the industry are using if they don't have something themselves or they're just curious. And it's very easy to then take the quality metrics and convert that into a cost saving. And also, even beyond that, I think it gives developers a sense of pride in the fact that they're tracking, improving quality, they're delivering faster, and they're reducing technical debt and good things that are close to the hearts of developers.
Right. John, how have you seen customers improve costs and quality?
A lot of what I've seen is the reduction in issues. So as they have shifted left, they can see by a reduced bug count, for example. And the Z-Advisor is one of those perfect tools to show that, because it does have an integration with some of the bug tools such as Jira. One of the other things that they've seen is that innovation is quicker. So one of the things of identifying waste, there's so much manual work that is still being done today, doing the same tests over and over again, and very few people have actually taken advantage of doing automation. By automating, you free up your developers to actually do what they want to do. As Elizabeth said earlier, it is called grunt work. Documentation, testing, QA is always seen as, oh, I want to do that. Well, now you're empowered. You're responsible for the whole picture. So you want to be efficient in how you do it. And what they've seen is customers have been able to get more innovation out in the same amount of time compared to a waterfall. They actually get quite a bit more out. The waterfall method could take a year to a year and a half. And when you have smaller iterations, you may have a month, a quarter, or whatnot. You get that little bit of innovation going out. You get to fail faster, so you know what's not going to work without having to wait that long period of time. By having those shorter cycles, you can react to the market better. They retain customers, so the net promotion scores are much better with customers when you have quality, new innovation coming out to meet what they want. So there's a lot of stuff. You're still paying the salary for a developer if they're coding or if they're doing manual tests. Why not just have them code? Put all that testing into automation, and that'll help you in the long run.
All right, it's a great point. I think that's a good place to end it. So Elizabeth, John, thank you for joining us today. This was a really good conversation.
Thank you for having me.
You're very welcome, and please reach out to us if you've got any questions.
Indeed. So thank you to everyone listening today. I'll put some links for further information in the show notes. We hope you can join us again on the Modern Mainframe. Until then, take care. You're listening to the Modern Mainframe, BMC's intelligent Z optimization and transformation podcast, covering the latest trends and issues on the mainframe and how BMC AIME and BMC CompuWare Solutions can help you build a mainframe-inclusive DevOps toolchain.